Hey, this is Mariam Abuhamra from Tutor and Excel, and today we are going to do some practice problems about geometry proofs. So we have this question over here, and the first thing you want to do whenever you're doing a proof diagram like this is you want to see what information you're given. So they give us that angle 1 is complementary to angle 2, and angle 3 is complementary to angle 4, and that line AC is a median. So what does complementary mean? Well, we remember that when two angles are complementary, that means that they add up to equal 90 degrees. So we're going to write that under our statements. So we're going to put angle 1 plus angle 2 is equal to 90 degrees. And the reason for that is that they're complementary. That is the definition of being complementary. So we're going to put that as given. We also know that by the same rule, angle 3 and angle 4 are going to be equal to 90 degrees as well, because that is also given. And we know that a line AC is a median. So by the definition of a median, we're going to write the definition of median over here. And a median is a line that starts at a vertex and bisects the side opposite to it. So what bisect means is that the two sides on either side of where the line intersects is going to be equal to each other. So we know that this line and this line are going to be equal to each other because this is line AC. Before we continue, we also want to know what we're looking for or what we're trying to prove, which is that the triangle ACB, so ACB is congruent to the triangle ACD. ACD. We're trying to prove that. And to do that, we can use one of our congruence postulates, which would be including side, angle, side, 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 angle, 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 or angle, angle, side. Now, I also want to make sure to know that you remember side, side angle is not a congruence postulate, okay? So we have to prove one of these to prove that it's congruent. And what we're going to try to do, because we have that this is a right angle and this is a right angle. So we're going to use substitution to show that these two angles are equal to each other. So we're going to do angle 1 plus angle 2 is equal to angle 3 plus angle 4. And the reason we know that is substitution. Now, in case you didn't understand what I did there, because this is equal to 90 degrees and this is equal to 90 degrees, we can substitute this for this side of the equation. And that's how we got this. Okay. So now we've proven that the two angles are congruent to each other. What we also want to prove, we also need to include in our proof that we've already included in our graph is that these two sides are congruent. And so the way we would write that under statement is you would do line BC, and you put a line on top, is congruent. This symbol means congruence to line CD. So now we're going to put our reason for why it's congruent. And the reason we know that is what we said earlier, because line AC is a median. And the definition of median is that it's going to bisect the side opposite to it. So we're going to put the median, the line. So line, or we can write it like this, B, D, and then we put that on top just to say that that's a line, is bisected by median AC to at point C. So that's our reason, because BD, this line, is bisected at point C. And that makes these two lines congruent because of the definition of bisected. So now we have side, angle, and what we need is another side. And we can look at this one in the middle, which is equal to itself. So line AC is congruent to line AC. And in geometry, we call that the reflexive property. So that's what we're going to put in our proof, which is that anything is equal to itself. A is equal to A, B is equal to B, and line C, AC is equal to line AC. So now that we have that, let's just make sure that we have our side, angle, side. So we have a side here, an angle here, and a side here. So we have our postulate, which means the last statement we're going to make, if you can guess, is going to be this one, what we're trying to prove. So that's going to be triangle ACB is congruent to triangle ACD. And what we're going to put for our reason is the side, angle, side postulate. So side, angle, side, congruence postulate. And we've completed our proof. Now, looking at this next question, I want you to try to pause the video and try to solve it by yourself. Okay, so if you remember from what we did on the last one, we're going to start by writing down our givens. So we know that line RN is congruent to line GC. We know that line NT is congruent to GE, and we know that EG is perpendicular to RC. And all that means is that they create a right angle where they touch or intersect. And we know that NT is perpendicular to RC. And these are all given. So they gave us a lot of information here, and we're going to mark it on the graph. First, what we're going to do though is we're going to box what we're trying to prove. So we're trying to prove this triangle, EGR. Okay. So it's going to be EGR to TNC. TNC. Okay, so we're trying to do those two triangles. Now let's mark the information we were given. So we know that RN and GC are congruent. So Rn and GC are congruent. We know that NT and GE are also congruent. So NT, which is over here, and we put 2 lines because this is a separate congruence. And that's just to make sure you don't confuse this line with this line. So we're going to put that that's congruent to line GE, which is over here. Now we also know that EG and RC are perpendicular to each other. So what we're going to put is a right angle there, because that's what perpendicular means. So we find EG and we put a right angle, and we find NT and RC and we put a right angle. So far what we know, we have a side that is congruent to both of them. We also have an angle that's congruent for both of them. And so all we need now is another side. So let's try to prove that one of the sides are congruent. And we're going to try to figure out how we'll do that. So for this line, it's congruent to this line. And so I think I see a way how we can prove this one. So we're going to try to prove that one. We'll start by noting that this line is equal to line Rn plus NG equals RG. And we know that line GC plus NG is equal to line NC. So what we're going to do for both of these is that the sum of a whole is equal to the sum of its parts, which is part of the partition postulate. So that's what we're going to write for our proof. The partition postulate. And in our notes, we're going to write the definition of this so that we won't forget. If you ever get stuck and you don't know how to prove that 2 triangles are congruent, a good thing to do is to just go online and search up some geometry theorems to see if any of them apply to your triangle. And sometimes it can be a bit difficult to see where to start from. So just choose a certain side or angle and try to see if you can prove that they're equal to each other. A lot of times, like with this problem, you're going to already have from the beginning 2 sides or 2 angles that are already equal to each other. So then you'll already know which one of these to go for. Since we already had a side and an angle congruent from the beginning, we knew that we would try to prove this one because we were already given that information. So continuing to where we were before, now that we use the partition postulate to make these equations, we can use substitution to make these equal to each other. So we're going to do okay. So we know that Rn and GC are equal to each other. And we know that NG is equal to itself because of the reflective property. So we can substitute we can substitute RG for GC plus NG because we know that RN and GC, is difficult, because we know that RN and GC are congruent. So we can interchange these two. And because of the reflexive property, we know that these are also congruent. So we can put RG here and we get the line of RG is congruent to the line NC, or in this case, we would probably put equal to because we're doing an equation. And we're going to put substitution. So now that we proved that RG and NC are congruent, we have enough to justify that triangle EGR is congruent to triangle TNC. And that is because of the side angle side congruence postulate. And let's just verify that that's true. So we have a side here, we have the right angle, so that's an angle, and we have the other side here, so that's another side, and that's side angle side. And we solved that problem.